Okay, in this video we're going to look at some ways of working out the area of triangles. So you're probably all familiar with this simple formula for working out the area of a triangle, which is if you know the base and you know the height, then the area will be half times the base times the height of the triangle, where the base is this distance along here and the height is this distance from the base up to the peak. We can shorten that to half BH, half the base times the height. Okay, but what if we don't know the height, as we often don't? Often we only know the side lengths around the triangle A, B and C, and maybe the angles as well, which would be C, B, A in this case. So what if we're in that sort of position? How are we going to work out the area of the triangle? Well, let's say we know A, I'll make this one down the bottom B, and I'll make this one C, and we know these angles around the edges as well, so that would be B there, and that would be A there. Well, how can we work out the area of the triangle using those quantities? Well, we can actually use our trigonometry rules that we've been learning to work out that thing down the middle. Let's call it H, that line down the middle, and that'll allow us to use this equation again. So let's say we know this angle C and we know A, so we know those two things. We can work out H using Sohcahtoa. If we consider that by drawing that line down the middle, we're creating two right-angled triangles. Let's look at the right-angled triangle on the left. If we focus on this angle here, C, if we call that theta, then this angle here would be the hypotenuse, this angle along this side, and this angle, so this line in the going down the middle, which we've called H, that would be the opposite. So we'd be able to work out using Sohcahtoa, we'd be using the sine part. It'd be sine theta equals the opposite over the hypotenuse, which in this case the opposite is H and the hypotenuse is A, side A. So if we rearrange that to find H, then we'd multiply both sides by A times A times A, and we'd end up with H equals A sine theta. And so if we put that into this equation now, we've got a different version of H here. The area of this triangle, of this green triangle down here, is going to be half times the base, which is B. I made B, side B the base, times, instead of H, we're going to write A sine theta. A sine theta. So it's really the same equation as this one here. You can see how similar they look. The only difference is instead of H, because we didn't have H, we had to use A sine theta to find H. That's what Sohcahtoa taught us, that H is the same as A sine theta. So now we've got an equation we can use to find the area of triangles. If we know the angles around the outside, and we know the side lengths. Okay, but there's other situations we might be in where that won't work, so let's look at those. Oh, and I should mention that we should be aware that if the triangle was labelled differently, if we were trying to work out the area and we had a different set of values, say we had C instead of A, we knew this side C and this angle here A, then the situation would be the same, but we'd just have to write the equation slightly differently. We'd write area equals half times the base, which would still be B, and we'd multiply it this time by C sine A, which would be this angle here, because that's still going to give us the the line down the middle, which would be the opposite. This would be our theta, this would be our hypotenuse, and this would be our h. Same result, just a different version. And of course you could, depending how you've labelled a triangle, you could twist it all kinds of different ways. You just have to look at the situation you've got and draw a line down the middle, and then choose the right value of with the right side and the right angle to work it out. Okay, the other way we can work out the area of triangles is the situation where we only know the sides and we don't know the angles. Well, of course, if we know the sides, we could work out the angles using the cosine rule, but there's actually a way to find the area of the triangle without having to do that, without having to find the angles and then follow the method we just looked at. We can do it just with the sides, and we do that using Heron's formula. It's a special formula. I'll write it out for you. Okay, here's Heron's formula. It's the square root of this value s, which we'll look at in a second, times s minus a, times s minus b, times s minus c. So all we've got to know is these four values, s, a, b, and c. A, b, and c will be the side lengths, and s, well, what's s? Let's look at what s is. S stands for the semi-perimeter. The semi-perimeter just means half the perimeter of the triangle. Okay, perimeter means to measure the distance around the edge of something. So the perimeter goes all the way around this triangle. Okay, and half the perimeter, or the semi-perimeter, is going to be half of the distance around the triangle. So to find the distance around the triangle, you just add the three sides a, b, c, a plus b plus c, and then times it by half, and you got half the perimeter. So that's what s is. So you just plug in s, a, b, and c into this formula, and hey presto, the area will come out. Just remember that whatever the sides are measured in, if they're measured in centimeters or if they're measured in meters, then your answer is going to come out as centimeters squared if the sides were measured in centimeters, or it could be meters squared if the sides were measured in meters. So don't forget to include the units in your answers. Alright, let's do a couple of problems where we can apply these two methods that we've learned for working out the area of triangles. Okay, here's a problem from your textbook which we can try and work out. So in this first question, we're told that side A is 7, side B is 4, and angle C is 68. Let's draw a diagram of that, see if we can find the area. So we'll call this side A, angle A, angle B, angle C, side C, side B, and side A. Okay, now we know angle C is 68 degrees, so we can put that in. And we know side B is 4, and we know side A is 7. Okay, we've drawn our diagram. Now to work out the area, we need to know this distance along the down the middle of the triangle from the peak down to the base, and then we can use our formula area equals base, half the base times the height. Okay, so we know already, we know what half is. The base is going to be 7, that's A, and we just need to know this value here, h. Alright, let's work out h, the height. So if we've got this angle here, and we know this side of the triangle over here, we've created this right angle triangle, and we know the hypotenuse length, then we can use sine theta equals opposite over hypotenuse, and opposite is h, and the side length is b, which is 4. So sine theta equals side h over 4. And we want to find out what h is, so that's going to be times 4 on both sides to get h on its own. So h equals 4 sine theta, and theta is 68 degrees. Okay, so we can put that into our equation, half times 7 times 4 sine 68 degrees. That should give us the area. Let's put it into a calculator. Okay, so here you can see we've written into the calculator the formula that we had with all the values. When we execute, it says 12.98. So we can write here that equals 12.98. And since, well, we didn't have any units, but if we had if these had been in centimeters, these side lengths, 4 centimeters, 7 centimeters, then this would have come out as 7 centimeters squared. So there's how we work out the area using that method. Alright, let's work out the area of a triangle using Heron's formula. Okay, this is another question. Let's say we've got a triangle with side lengths 5, 6 and 8 centimeters. We can call that one A, this one can be B, and this one can be C. So let's say we've got that. Let's find the area of this triangle. So let's label it A, B and C. A is 5, B is 6 and C is 8. Okay, now we only know the side lengths here. We don't have any angles. We could work them out, but we can use Heron's formula. We don't have to work out any of the angles. We can just go straight to Heron's formula, which says area equals the square root of S times S minus A times S minus B times S minus C. And where S is half A plus B plus C. Okay, so all we've got to do is put our values into this equation and we'll get the area. First of all, let's work out S, the semi-perimeter. For this triangle, we've got to go half times A plus B plus C. A is 5, B is 6 and C is 8. So 5 plus 6 plus 8 equals 19. So it's going to be half of 19, which is 9.5. So S is 9.5. So now we can put everything into the equation. Area equals the square root of 9.5 times 9.5 minus 5, 9.5 minus 6, and 9.5 minus 8. Okay, let's put that into a calculator and see what we get. Okay, so I've put all our values into the calculator, as you can see there, and I've also put the square root in. So when we press execute, we get 14.98. So the area of this triangle equals 14.98, and whatever the units would be, let's say these were all in meters, all these side lengths, then it would be meters squared. But if you're not given any units, you don't have to put them in. So 14.98 is the answer. Okay, let's wrap this up with a summary. Okay, so here's a summary of what we've covered. The formulas for the area that we've looked at are half times base times height, half times base times a sine of angle C, where you're in a situation like this, you know angle C, you know side A, and it allows you to find this side H. So not this side, this distance H. And of course you could rearrange that. You could make it, instead of having A sine C, you could have C sine of A. Or you could use this angle here, B, and the triangle would go, the height would go from there to there, and you'd be using this side here, A. So it depends how you cut the triangle, which values these take on. And there you have it. So copy those into your book, and thanks for watching the video.